So where are we at? Ooh, look at these guys. See my little penguins I drew? Aren't they cute? Okay, let's see. So we've done 4 and 6 and 8. Let's do 10 and 11, and then I'll go back and get 9. Good? All right, so moving along. Number 10. Oh my gosh, there are 3 boxes. Ugh.
Humanity.
No, all right. The figure shows 3 crates being pushed over a concrete floor by a horizontal force F of magnitude 440 newtons. Their masses are blah, blah, and blah. The coefficient of kinetic friction. Thank you. Work ahead if you're that conscious of stuff. The coefficient of kinetic friction is 0.7. So, A says what's the magnitude of on crate 3 from crate 2. It's actually really similar to the one we just did. The main difference is you need to manually find your forces of friction instead of just them being handed to you. Okay? Yeah. Sorry? Yeah. Oh, incidentally, one of my calculators wandered off. I don't know if somebody borrowed it, but if so, I would like it back. Hey. You mean like come up and solve it?
No, just like,
Yeah, actually, so I gave like a...
no, McKeever, can you go up?
No, okay, well, like, I had a solution that I really liked.
Come on up. Yeah. You guys gotta get tired of hearing me blab.
Professor McKeever, I was really backwards and bad.
So, like...
There you go.
So, I mean, if you want to do it quickly, you can just... If you want to do it quickly, you can just make, like, one big system of 60 kilograms, and find the force of friction, then find the acceleration on the system, and then use that to find the force of friction on everything.
Yep.
But if you want to do it really weird, you can...
All right, let me just say one real quick thing about what you just said. So what he just said was you can find the force of friction in sort of one fell swoop by using a 60-kilogram thing.
Yeah.
That only works because the coefficients of friction are the same for all 3 boxes. So you could also do them separately, which is what I did in the example in the notes.
Okay. So, you can create... This is going to take me a while to write out.
It's okay.
You can create 3 systems of boxes. 44 omega. And then...
That's a 440. He's good.
Yeah. Okay. Did I solve these yet? Oh no, wait. No, I solved those, okay.
No, I like where you're going here. This will work.
Yeah, okay, so...
You're good. So once you get all this written out, let's pause and make sure everybody's on board with you, but I think you're good.
Oh yeah, and then X right here. X, and back against each other.
Hashtag summer 2
Y. I can't see my...
I know, yeah.
Yeah, that's difficult.
Throw out some hashtags.
I just think this... I mean, this would also work if the coefficients were different.
Yeah.
So I like this. And then... 130. And these are...
What he's doing here, you guys, is a thing that sometimes will be helpful when you're not given numbers.
Yeah. So this is everything. I found those from it's just calculating friction.
All right, so let me pause you for 1 minute. So everybody take a look. Can everybody see? I'll just scoot so people on the side of the board can see. Can we make a little key over here? So what is your X is the force of...
I guess A on B or B on A.
A on B or B on A, and your Y is the force of B on C.
Yes.
Is that right? Does that jive with the letters in the problem?
Actually, 1 on 2 and 2 on 3.
Oh, 1 on 2 and 2 on 3?
That's it, Y.
All right, so are these right now? I guess I could just look.
Yeah, they should be.
Yeah, that's correct.
The 1 and 2? Okay, so he, instead of using F12 and F21, he just called them both X. And instead of using F23 and F32, he called them both Y. Good?
Yep.
And talk to me about these 3 dudes here. Is everybody cool with where he got those?
No.
So how about Patrick? Where'd you get those?
The mass, 0.7. So mass times g times 0.7.
Yeah, your normal force equals your force of gravity, so that's the force of gravity times the coefficient of friction, which is 0.7.
For all of this.
Follow?
Yep.
So what he's done here is he's created a free body diagram for each of the three masses individually. Follow?
Yep.
All right, right on. Cool.
And then from there,
So, let me give you a new page.
sweet. This is gonna be a lot of writing. See. So first I created equations for the accelerations on each box.
Okay. So when you, yeah, go ahead. I'll shut up.
So this is what turned blue? 2 minus x, and that's the that minus that
Cool.
minus x divided by 30. That's acceleration on that is equal to y minus 137. Well, that's actually that's the last one. Basically, what I did was I made everything equal to each other, and then I just used one of them, and I cross multiplied, and then I substituted the variable in. Should I write it all out?
Yes.
Yes.
Okay. And then,
So basically, you guys, what this is going to boil down to, he's got two variables here, right? X and Y. And he's going to use the fact that all three of these objects have the same accelerations, right? Or acceleration, if you prefer. That's not a word. All right.
then
So he's basically coming up with three systems of
I can't say in my head.
two variables,
Yeah.
and we'll basically end up with two equations.
Wait. I can't do this in my head. No, that's 4116.
Oh wait, what's the 30y minus 416? You didn't go in the direction I thought you were going to. Oh, you cross multiplied. I see.
Yeah.
I gotcha.
Way to do it.
Yes. So, what do I want to say here? Can we do one of the? So what you've got here is you've got an expression for this one and an expression for this one, right?
Yes.
So, do you guys agree that we could use this to write one equation that's in terms of x and y?
Yeah.
Right? Can I step in for a second? No, write one for this. Write a third equal sign for this guy.
Oh yeah.
Or is that where you're headed?
That was where I was headed.
Okay, I'll shut up then and let you work.
Okay.
So you just cross multiplied there, right? That's what you're working on right now?
4704. I think.
Well, oh, I thought
Okay.
McKeever is a
I think I solved for y. Yeah.
he's going on.
Yeah, there's a bunch of ways out.
That's an 8.
So while he's doing this, you guys, grading Patrick's test is always a thing. Because his solution is always like, everybody else did it like, oh, and then Patrick's like, oh, but I'm going to do it this totally different way. And it works, but it's just, it's funny. That, you know,
And
it's,
then get that, and
All out, and then
will that work?
Yep.
Extend. Cool. Okay, and then from
let's
there.
let him finish, you guys. All right, so he basically he cross-multiplied and solved for y.
This is where it gets.
Why don't you swap, you want to swap colors?
Sure.
Oh, hang on, we lost Carla. Scroll up, he needs to,
So I also have a question. What's your character next to the 20?
it's 8820 minus
Oh wait, where?
20x over 30.
X? Okay, I wasn't
Patrick, you know, in Russian,
By that.
Okay.
Okay. Well,
All right, let's,
okay. So then from there, you just write x minus. Oh wait, this is, by the way, I'm substituting. Should I write out the equation first before I substitute?
yeah. So now you're going to write an expression for the 10 kilogram
Yeah, the
thing,
10
right?
kilogram one. So x minus 60 minus y by 10, and I can just set that equal to
Any of
one-
the others?
yeah.
Okay.
Preferably one with x in it, so I don't have to deal with y twice.
Yeah.
Okay. And then substitute in.
Substitute in and solve it.
Yeah.
I think
get
you're
where
good
I'm
from
going.
there, yeah?
Yeah.
All right. That's really cool.
Makes a lot more sense.
Okay. That was funny. All right. So let me say one thing, and then I get to questions there. All right. So there are a bunch of ways you can navigate this problem. All right. I don't know that I would have gone about it exactly this way, but this totally works. But at the heart of what he's doing is this idea here, where you're recognizing that the system and each of the three individual objects all have the same acceleration. Okay? And then you need to work in combinations of those things to solve for the missing variables. Okay? So, very cool, Patrick. Sarah, you started to ask something.
That's okay.
You sure?
Yeah.
Okay. And if you have other questions, because this was a little, I'm happy to work through it with you. All right. Okay. So what number was that? 8? Or that was 9? 10. Okay. All right. So we got to do 11 next, right?